First question says, which technique is used to purify the solid obtained from a chemical reaction? What do you guys think the answer is? Please let me know in the chat. I'm going to wait a couple of seconds to give you guys an opportunity to answer as well. But the key word here is to purify a solid. So if I'm purifying a solid, am I going to be distilling something, evaporating something, or filtering something? Remember, we're purifying a solid. Crystallizing as well, we're filtering. Okay, someone said filtering. We also have C. I have a question. Do you think I have time to revise the whole book of chemistry perfectly? You do. You still have time. Try to join a crash course, or try to compress the information you know. Okay, a lot of people are saying C, but we also have answers of B. So the key word to look for when you're answering is the fact that it's a solid. So the fact that it's a solid tells me that the answer has to be C. Okay, because when you distill something, when you're filtering something, you're also involving liquid. Okay, so distillation, evaporation, I'm going from liquid to gas. And that's why I know my answer is going to be C. That makes sense, everyone. Someone said I'm still in DP1. Oh yeah, if you're still in DP1, you can go ahead and review the whole book. You still have lots of time. Okay, the next question says, ice containing only the isotope 2H sinks and does not melt when dropped into an ordinary distilled water maintained at 3 degrees Celsius. Which statement is correct? What are you guys thinking? Please let me know in the chat. And also a good way to study for your exam is to do some active recall. So give me an answer and then maybe in another comment tell me why you chose that answer. It'll help you study. Okay. This light's a bit annoying. Let me see if I can somehow close the light, but does anyone have an answer? So you haven't got an answer yet. Is this standard or higher level chemistry? This is standard level, but if you're higher level, you should be able to answer these as well. I'm just going to go ahead and close the window so that the light doesn't bother you guys so much. Okay, someone said C or B. Okay, if you said C or B, I want you to think about the density. Is this possible to have a lower density? Think about whether it's floating or if it sinks. So connect those two things together. I'm going to be right back. Okay, a lot of you guys are saying B. Whoops, then it might be. Exactly. Good job, guys. It is B. The answer is B. Let's have a look at the answer options to see why B is correct. So it says the isotope has, so the isotope H2 has a high natural abundance. This isn't correct, first of all, because the one on the periodic table is the H1. So we know the one on the periodic table is going to have the higher abundance. So it's not A. Then let's have a look at C. It says H2 has a lower density than normal ice cold water. Of course, it does not have a lower density, because if something had a lower density, it would float. Okay, and since it doesn't float, it sinks. It means it has a higher density than ice cold water. So that's why C is incorrect. Next, it says H2O has different chemical properties from normal water. So this is a very, very common misconception. I beg, listen, okay? So in IB, when they're talking about isotopes, they want to trick you. Remember that always isotopes, the only thing that is affected between different isotopes is the physical properties. Why? Because physical properties like melting point, boiling point, they're all dependent on the mass. Okay, the mass and the bonds, like the LDF bonds, the hydrogen bonds, and so on. So whenever you think of isotopes, because they weigh differently, they're going to have different physical properties. Now, when we're thinking about chemical properties, that's a big red flag. Whenever you see chemical properties and isotopes together, just already cancel that out as an answer option. They're trying to trick you because chemical properties depend on the electrons. So a difference in chemical properties would be things that have different ionic charges, for example, Na+, Mg2+. Just think of always chemical property in relation to electrons and think of physical properties in relation to mass and bonding. So that's why we can already cancel this one out, because we know they're trying to trick us. That's why my answer is B. Next, it says which electron transition in the hydrogen atom emits radiation with the highest energy. While you guys go ahead and answer this, I'm just going to double check the chat to make sure. Do you know how I could study chemical equations quickly? I have an exam tomorrow and don't know anything. What do you mean by chemical equations? Can you explain the topic a bit more? Okay, I'm getting DAC. Oh, wow, there's a bunch of different answers in the chat. D. I'm getting another D. Another D. Ooh. So do you guys remember this diagram? I'm going to try to draw this and tell me if you change your answer. Okay, some people are saying it's A. Okay, so hopefully you've seen something like this before. And it represents the energy levels in an electron. And actually, I drew it a bit wrong because you have to show convergence. So then getting closer and closer and closer and closer, whatever, like this. Hopefully you've seen this before. And you know we have energy level 1, we have energy level 2, we have energy level 3, and so on and so on. We know that energy level 2 is what? That is just real visible light, okay? Energy level 3 is infrared, and energy level 1 is UV, okay? So a jump from anything to the UV is going to be emitting the highest energy radiation, okay? That's why my answer is C, because remember, you have to know in the IB which each level corresponds to, depending on the color and the exact energy it releases. And because we know by looking at the electromagnetic spectrum that UV releases the highest energy, that's why my answer is C, because it's going from level N, which is, N2, which is the real visible spectrum, to N1, which is the highest. Does that make sense? Can anyone tell me some active recall? Try to tell me, would A be emitting or absorption if I'm going from a lower one to a higher one? If there's no C, what's the answer? If there's no C, then, so I was just going to get to that. So basically, very good. Someone said absorption. So if I'm going from a lower one to a higher one, that's absorbing. And again, so that can't be A. If I'm going B as well, if I'm going from a lower one to a higher one, that's absorption. And the key thing in the question says emitting. So then if there's no C, then I would have to say, of course, that the answer has to be D. Okay? But otherwise, of course, there is the answer C, so the answer is C. Higher to lower is emitting, lower to higher is absorption. Very good, guys. Energy level gets smaller as you get further away from the nucleus, so C. Perfect. Okay. Next, it says a container holds 30 grams of argon and 60 grams of neon. What is the ratio of the number of atoms of argon to number of atoms of neon in the container? And for this, we don't need a calculator, but you do get a calculator in your exam. The new chemistry students are lucky. When I had my exam, we didn't have a calculator. Thank you, someone. Thank you very much for your compliments. All right. Why not D for 3? Okay, why not D? Because I'm going from the infrared, the real visible to infrared, and I know infrared is not as strong as UV. So go and reflect back to your electromagnetic spectrum. All right, nice. Perfect. Okay, I hope you guys, the other students who've been working on this one, I'm a bit behind, but I'm going to search up the periodic table so I can find the molar mass of argon and neon, because can anyone tell me what type of question this is? Is it what unit maybe can help you remember as well? So the reason I'm looking for the molar mass, are you recording this so we can watch it later? I am, and it's going to be off on YouTube. If you guys are looking for more content than this, we also have our chemistry crash courses that are about to start in, not this weekend, but next weekend, so you can also join them. And we teach basically the whole syllabus in 5 days. Well, I'm going to teach the syllabus in 5 days along with my co-tutor. Okay, so argon has a molar mass of 40. It's 39, but I'm just going to round up for the sake to be 40. And then neon has a molar mass of what? Of 20. Okay? So why am I even doing this? I'm just going to write it down so I can not forget. But why am I even doing this? I'm doing this because this is an empirical formula question. I'm trying to find the simplest whole ratio. And always when you have the simplest whole ratio, it's telling me to find the ratio, what am I trying to do? Find the number of moles. Very good. Someone said find the number of moles. Exactly. So always try to find the number of moles. How do I find the number of moles? I go grams divided by molar mass. That gives me the number of moles. Once I have the moles, I'm going to try to find the ratio of the moles. In simple terms, I just divide by the smallest one. It's always the exact same for empirical formulas. Find moles, divide by the smallest one. That's all you have to remember. If your teacher is telling you do more or remember more, literally push that out of your brain because you don't have to. So the first step is to find the moles, grams over the molar mass. My argon is here. Okay, so that means I have 3 out of 4 moles of argon. Then my neon, hopefully you guys can see this blue, it's a bit bright. My neon is going to be 60 over 20, which is going to be 3. So I have the moles of 3 over 4. So this for argon and this for neon. So now that I have the moles, what am I going to do? I'm going to divide by the smallest one. The smallest one, of course, is not going to be... Sorry, I'm just doing on the calculator quickly. So this is equal to 0.75. So I divide this by 0.75. Okay. So 3 to 4 to 3. This can be argon. This can be neon. Okay, so what's the next step? I'm trying to find the ratio between argon and neon. So, oops. You can divide by the smallest one, but there's actually an easier way. So I'm going to show you now. Basically, because I'm trying to find the ratio of argon to the number of neon atoms, that's the same thing whenever you're trying to find the ratio in this term. It's just saying argon divided by the number of neon atoms. Because just like you would do in math, when you're trying to find the number of, for example, blue balls to red balls, you always do the blue balls divided by the number of red balls. Okay, that's the same exact thing here, but we're looking at argon and neon. So I'm going to do 0.75 divided by 3, and that's going to give me 0.25. And that's why my answer is A. Does that make sense? Well, how I got A? Please let me know in the chat. I'm just going to... This look here reminds me of the test to enter med school. Oh, yeah, those were horrid. I can also use Avogadro's number to find the... I would not use Avogadro's number because then it would get too complicated. And also, what's nice about Avogadro's number is the same. It's 6.02 times 10 to the 23. So even if you multiply both of the moles by 6.02 times 10 to the 23, it's kind of redundant. You're just doing an extra step. Yes, it makes sense. Yay, okay, good. Where did you get these questions from? They're just the specimen papers. Just search up on the Google, like IB chemistry specimen papers, you should find them. Okay, nice. Okay, this one is a bit hard. This is mean for IB to pull because they've never pulled something like this before. So I would expect them to pull something similar on the exam because usually the spec papers are easier than what the actual exam is going to be. So if they put a question like this that's harder than normal or irregular than normal, it means they might bring this up on the exam. So focus up on this question, okay? So it says a gas storage tank of fixed volume V contains N molecules of an ideal gas at 300 Kelvin with a pressure of 40 kilopascals. N4 molecules are removed and the temperature is changed to 450. What is the new pressure of the gas in kilopascals? So usually you get this type of question in past papers, in a bunch of specimen papers of just volume in relationship with temperature or pressure. But here, it's a bit different because we're adding something new, and this is where IB went a bit rude with this number of molecules. But if you know how you derive that specific relationship, you should be able to answer this question. Okay, are these courses recorded? So the live is recorded. If you're talking about our crash courses, they are also recorded, and you can join our website, and then you just like follow the crash course as you normally would follow a course. It's online. And you like do a subtopic, press next video, subtopic, next video. But if you're talking about this specific thing, it is on YouTube. Okay, I'm just gonna wait. We also provide physics crash courses. Not this year. I really wanted to do a physics crash course this year because I studied physics in university, part of my med course. So I said, okay, maybe now I can start teaching it. But we postponed it to next year because of the time. So if you are an M26 student, that would be good. N1 is just N, but then N2 would have to be N4. Yay, okay, if you're M26, you can sign up to our waitlist if you want, and then we'll email you when they come up. Okay, there's not a lot of answers for this one. So maybe I just work it out with you guys. Is that okay? Is this question looking a bit hard? Okay. N over 4. Very good, Ash. Exactly, perfect. So if we know that, maybe you guys know the relationship of PV1, T1 equals P2, V2 over T2. And if you know this relationship, you usually would have been able to answer any of these IB questions that come up. This year, they're a bit mean because they want to test the students' understanding. So if we know how this equation is derived, it's basically to show that, well, we also know that there's also another ideal gas equation, first of all, PV equals nRT. How is this equation derived? What does it show? It shows that PV divided by RT is equal to the mole. So when you have the same exact moles or molecules of a gas, and you just apply a different pressure change to it, you can sub it equal to another of these equations, okay, with the new applied pressure, with the new applied temperature, and then set equal the moles together. But that's only when there's the same amount of moles in the gas before you conduct the change and after you conduct the change. In this case, there's different amount of moles, but you still have to remember and apply this relationship of PV equals nRT and connect it back to this one. So the only reason we can say this is equal to each other is because we can say that they have the same amount of moles. But we can still apply that knowledge, okay, using what I've just mentioned. So how would you do that? You would just simply say, okay, so P1 V1 is equal to T1, and that equals n molecules. Okay, fine. And then I have P2 V2 T1, and that equals to n divided by 4 molecules. So the only way I just need to find P2, because I'm trying to find the new pressure change of this gas, is apply these two relationships. Okay, so what's our first pressure? Our first pressure is 40. They say the volume stays the same, so I can just cancel it out. My second temperature is, my first temperature is 300, and that all equals to n. And then I can say P2 is all equal to 405 n over 4. Okay, what can I do? I can just sub in n for here, and then solve for P2. So P2 is equal to 450, 40 over 300, divided by 4, and then I'm going to be able to solve for P2. So 40 divided by 300, divided by 4, times 450, should give you a final answer of 45. Does that make sense, everyone? And double checking calculations. Divided by 4. Ah, I see where I did wrong. Oh no, that's correct. 50. Perfect, okay? And that's why my answer is 45. My teacher is explaining this exact exercise and made it a lot harder. I'm a bit confused. Okay, if like 3 people in the chat tell me to re-explain it, I will. But I know a lot of other students get really annoyed when we go a bit slow. So if you want me to re-explain this, I can. Should I re-explain it? Just text in the chat and I'm happy to. Why is it not 3n over 4? I'm confused, but understand. Thought process. Re-explain. Okay, let's re-explain. Okay, so hopefully you guys understood where I've derived the equations of like PV equals nRT and this exact thing here. So PV equals nRT is the equation we know, okay, of real gases. And we also know this P2V2, T2, P1V1, T1, okay? This we understand. Now, we know that this equation, this relationship, was derived by applying this law. By just dividing R and T by PV, we derive this law saying that PV, R, T is equal to the number of moles. So they said when you have 2 or 1 gas and you apply a change to it, so let's say you try to decrease the pressure, but you try to increase the volume, it's still going to equal the same number of moles. Because no matter if you increase the pressure or the temperature or whatever you do to this gas, you cannot change the number of molecules. You cannot change the moles, okay? So they've derived this equation by just setting, okay, this first pressure, first temperature, and first volume is equal to directly whatever pressure change we do, and that ratio, they're still equal to the number of moles. So they've derived, so they've derived this equation. Now, this equation is usually all you needed to know to answer these questions. But now the IB have been a bit rude because they want you to always know how this equation has been derived. So you can apply this knowledge to answer the question. So I know that P1, V1 over T1 You can even add the R if you'd like, but it's redundant because the gas constant is just going to be the same on both sides. Is going to be equal to usually P2V2 over T2. And that always equals to the number of moles as well. But now we see that the moles has changed. You've removed a lot of it. So N divided by 4. N representing the number of molecules. You can also think of it as the number of moles. It's the same thing, okay, in this case. So what can we do? We can use these two equations and connect them to each other. Of course, here there's also a gas constant, but we've canceled it out. So P1, they told me to be 40. They told me that the volume is constant, so I can cancel out the volume. And then I know it's going to be 400. So, 40 divided by 300. And then that's going to be P1 and T1, and that equals N. And then I know the second pressure is what I'm trying to find. My temperature is going to be 450. And I know my final one is going to be N over 4. So what could I do, just like we normally would in math? We just substitute this into here. Okay, so now I have P2, 450 is equal to 440 over 300 divided by 4. Once you do that in your calculation, you will get that the difference is 15, okay? Now, why is the answer 45? Well, because the difference had to be 60 minus 15 to give you 45. Why is it that case? It's that case because I've removed N over 4 molecules. So this is what I'm calculating, what I've removed from my equation. Now, someone said in the comments, can I also just say 3N over 4 in this case, and therefore I don't have to do the subtraction? You can, exactly. It's another way to do it. Okay, I'm just going to read the chat to make sure. Do you do bio? We do also do bio. We did the specimen paper. If you want to rewatch that, it's on our YouTube. And we also do have bio crash courses. Okay, if we know what N is, can we just divide by 4 to get the answer? Yeah, exactly, you can. Very good, it will be even easier. You get it now? Okay, nice. We're going to move on to the next question. It says, and I see that actually it zoomed out for you guys, which is a bit annoying, so I'm going to zoom in for you again. But this one should be an easy one. Why is it not letting me crop? What are we thinking for this next question? And hopefully you guys can see a bit better now because I've zoomed in. Okay. Someone said D. Oh, it's blurry. Oh no. From my end or your end? Because mine is clear. Maybe that's better. It says, what is the formula of the compound formed between magnesium ions and hydrogen carbonate ions? And then this is the answer option. Maybe it's better if I zoom in. It's not blurry? Okay, good. Okay, a lot of you guys are saying B. Very good. This is a simple question, and I would be very happy if this showed up on my exam. Why? Because I know that when I'm thinking about the formation of an ionic compound, all I have to do is crisscross my ionic charges. So Mg, oops, what happened there? Mg2 plus, and unfortunately, you do have to memorize the specific polyatomic ions. They give you a list in the syllabus, and you just crisscross, and that's why my 2 charge is going to be at the bottom here, and my 1 charge is going to be at the bottom here, but we usually don't write it out. Does this make sense, everyone? Okay, next one says, which species contains a coordination bond? And if you do the crash course with us, we have a list of all the coordination bonds you need to know for IB, so this would be much easier in the repetitive ones. And you would be able to just circle that one and move on. But there's basically some coordination bonds that the IB just love bringing up over and over again that we were able to create a list. Okay, so maybe when you're doing your past exam questions, you just create a list. Okay, someone said D. Nice, Kayla. I don't think you have anything else. Does B look accurate? What about A? Carbon dioxide. Do we know carbon dioxide has B? Someone said, do you have to pay for the crash courses or is it free? You unfortunately have to pay, but we offer the cheapest crash courses available. It's like, yeah, it's like £6 an hour, and you get 5 days. When does the crash course start? It starts not this weekend, but next weekend, because this weekend we're still doing the biology one. Okay, people said B. Okay, let's draw them out. So, or actually, maybe drawing them out would take too long. But carbon dioxide, we know, looks like this. Unless you guys want me to draw them out. Tell me I'll do whatever you guys want me to do. So if you want to, just tell me in the chat. For carbon dioxide, there's no coordination bond because we know that it just double bonds with the carbon. No, that's not how it works. CN, we know that that has a relationship like this. Okay. So it's definitely not going to be this one. Draw them out, please. Okay, let me draw them out. So how would we draw them out of carbon dioxide and HCN? You just use their valence electrons and you apply that theory. So how much valence electrons does carbon have? 4. How much valence electrons does oxygen have? 2. Sorry, 6. But it has 2 of those oxygen atoms. So we have 12. 12 plus 4 is going to give me 16. Then you divide that number of electrons by 2. And then you get the answer 8. So I know that I have to draw 8 sticks in order to draw my carbon dioxide. So I draw 1 stick, 2 stick, just to initially connect them. And then I have 1 stick, 2 stick, 3, 4, 5, 6, 7, 8. But what's wrong with this diagram? This diagram, we can see that carbon does not have 4 bonds. It only has 2 bonds, and carbon must have 4 bonds. So what actually ends up happening is this little bond here comes and shares it with oxygen. And this bond here comes and shares it with oxygen. We know a coordination bond, or a dative coordinate bond, is basically when one atom provides all the electrons for both of them. So one of them has no electrons, and therefore the other atom provides all the electrons it can get to the other one. And here we can see that they're not providing, they're sharing these electrons in the form of double bonds. That's why my answer cannot be A. Now here, same exact thing. Hydrogen has 1 valence electron, carbon has 4, and nitrogen, I believe, has 5. Hopefully I have remembered that correctly. Yeah. And then you have a total of 10 electrons. You divide that by 2, that gives you 5. So then you can say, okay, H, 1, 2. Hydrogen cannot form more than 1 bond. So then you can keep adding it here, like 1, 2, 3, 4, 5 maybe. And we see that the nitrogen is not satisfied, but the carbon is satisfied. So what do we have to do? We have to share our electrons with nitrogen. 1, 2, 3. And this is the only case where nitrogen is satisfied and carbon is satisfied. Moving on, we have NO2 plus. Nitrogen has 5, oxygen has 6. 6 times 2 gives me 12. So I have 5 plus 12 is 17. 17, subtracting 1 electron, because remember when something has a positive charge, we're subtracting. Okay, so instead of 17, it's going to be 16. 16 divided by 2 gives me 8, and I'm left with NO, is it NO2 or NO3? NO2, sorry, NO2, and then I just count 8 sticks. 1, 2, 3, 4, 5, 6, 7, 8. My nitrogen is not satisfied, so what's going to end up happening? This is going to share its electrons with nitrogen here and here. The same exact case as what? As our CO2. So even if you didn't know or didn't understand what was going on, you could have still said or guessed if CO2 and N2 have the same sort of bonding, then we can both cancel out. We can cancel out both A and C. Okay? Now let's have a look at D. Why is D our actual answer? We're going to look at it together. So if it's okay with you guys, I'm just going to erase these for space. But hopefully this made sense why this was like this. Okay, so now for space, I'm going to do the same exact thing. 5, and then 6 times 3 this time. It's going to give me 18. This is going to give me 5. And then I have to add 1 more electron because it's a negative charge. Oh, sorry. It's very zoomed out. Okay, next I have 18 plus 5, which is going to be 23, plus 1 is going to give me 24. 24 divided by 2 is going to give me 12. So I know that my NO3 minus is going to have 12 sticks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we know that this is going to contain a coordination bond because it only shares with one of these. Okay? So that's how we know this is a coordination bond, because we go from actually N like this, and we're adding an electron, it's negative, and therefore I'm adding this electron to what previously was, which is NO2. And I assume that's why they've added C to try to help you and understand that D is the answer. Did that make sense, everyone? Hopefully it did. The next question says, which properties depend on the movement of delocalized electrons in metal? And this one should also be sort of, not an easy one, but I think easier than what we'd assume. I don't know why I keep zooming out. I'm so sorry, guys, if this is bothering you. Okay, I see a lot of A's. A. Good job, guys. It is A, because we know what's special about delocalized electrons. They allow charges to be like passed on, right? So they allow charges in between these electrons to pass on, and therefore allows for definitely electrical conductivity and thermal conductivity between metals. And you can also think about what are the properties of a metal in general. Maybe you forgot in your exam what delocalized electrons do. You think about metal. Metals, we don't really talk about how dense they are, because you can change the density of the metal depending on how much volume or mass you add. That's why it's A. Very good, guys. Someone said, do you have a physics crash course? We don't, but next year we might add one. I was going to do one this year, but we didn't end up having time. Okay, have a look at the next one. And this is alloys as part of the new syllabus. So hopefully you guys are able to answer this depending on what you learned in class. If you haven't, don't worry, we're going to answer it together. You could answer this based on the old syllabus information. So based on just knowing, can you zoom in a bit? I'm trying. Sorry, guys. I'm new to this. Well, not new, but like I'm not used to it lagging on me so much. That's why. Is that better? What is your YouTube channel? It's just Easy7 IB Sciences. It should be. Where are the past papers from? They're just the specimen papers. If you search up IB specimen paper chemistry, you'll find them online. Or you could also join our crash course and they'll be available. Is this HL or SL? It's SL. But if you're HL, you're supposed to be able to also answer this. Okay. Getting no answers. Is this a hard one? It is a hard one. When I saw it, I was like, whoa. But we'll work it out together, so don't be afraid of this one. Think about electronegativity differences. I'll give you a hint. Does a metal have a high electronegativity or a low electronegativity? So your chem crash course starts next weekend. So not this weekend because we have bio, but the next weekend, yes. So join while you can, because I know a lot of people get annoyed when the crash course starts already and they miss out on a day. But don't worry, even if you join late, you can't see the question a bit. Sorry. It's just talking about whether this is an alloy. Even if you join the crash course late, you could still watch the recordings. It's really cool. It's like edited based on topic. So you like watch the topic, you do the practice questions, fill in the resource pack, and then you press next, and then just like you move on to the next topic and so on. But the benefit is, of course, that you join it live, because then you can ask the teacher in the Zoom chat, like, hey, can you redo this question? Can you explain this? I don't understand this. And it's actually cute, our Zoom chat. What topic is it? This one is topic, part of topic 1.1, I believe, of the new syllabus. It's just alloys. Will this be posted on YouTube? It will be. Okay, we have a D. Nice. I don't thinking of anything else. If not, I'm gonna go ahead and answer. So we still got quite a bit of questions. We're on question 9, and we have to get through all the 30. Wouldn't the electronegativity be a small number? Yes, for a metal you have. So remember always, metals have low electronegativity, okay? Non-metals have high electronegativity. Just look at your periodic table and remember this. So if something is an alloy a mix of a non-metal and a metal, or is it two metals? You should know this. An alloy is a mix of two metals, right? So if an alloy is a mix of two metals, that means, sorry guys, I see your questions, but let me just finish answering this and I'll answer them. So that means both of these, EX and EY, are going to be very low. So just think that for now, this and low. So the average between those should be very low. Okay, so if I'm comparing A, B, C, and D, of course it's very relative. I don't know. but it's not going to be my highest one because the average has to be very low. Also, when I subtract two low things, do I get a high number or a low number? I should get a low number. So based on the options, you have to kind of assume, it's really annoying when they give these questions because based on assumption, but assuming that both of these electronegativities are low and their differences are low, what can you do? You have to say that the answer is D because the average electronegativity between this is the lowest and the difference also will be the lowest. That's why my answer is D. Does that make sense, everyone? I failed my chem mock. Oh no! Okay, do some of these practice questions, and if you feel that you're doing okay, maybe there's still a chance. Someone said, when will the schedule for the crash course be out? It should be out this week, but I'll kind of give you like, it does not make sense? Oh yes, it does make sense. Okay, good. I'll kind of give you like a brief idea. So next weekend, what will happen is you'll have Saturday and Sunday, both SL. So you'll do like topic 1 to topic 6 maybe, or maybe 5. And then Sunday you will do like 6 to whatever 7. And then the next week, because it has to be on the weekend, because we know you guys still have school, Saturday will be the last day of SL. So finishing everything that's SL, maybe up to like 8 or 9. And then the Sunday will be HL, and then the next day will also be HL. So 3 out of the 5 days are SL, and they're on the weekend. And then 2 of them are HL. The reason why the schedule is not out yet is because we have to coordinate which topics are going to be like be able to be done on the days. But what's nice is that the chemistry syllabus, the old one, is pretty similar to the new one, so it should be pretty chill. Okay, let's do the next one. It says, which structure shows the repeating unit of a polymer formed by butane 1E? I'll give you a couple seconds to answer, and bio we finished this week. Yes, bio finishes this week, but the recordings are all available, so you can still join if you'd like. Someone said B or C. Okay. D, C. Okay, so I'm getting 2 C's. Just gonna scroll up to see. Is this GCSE or A level? It's IB. Oh no, someone said, can you explain again? Okay, so caveat. Maybe I'll go back and explain again when they're doing the next question. I'm sorry, I didn't see it earlier. Okay, I'm getting B's and C's and D's. Okay, let's go ahead and answer it. So butane 1E, the first step to answer this question would be to draw your polymer. So but means there's 3 carbons, and 1 tells me that it's on the double bond on the first carbon. So I know it's going to be something like this. And I'm going to go ahead and draw my butane 1E. I know that a polymer is all surrounding my double bond. So my focus is my double bond. So the first step for me to do is to draw my butane 1E focusing around my double bond. So what am I going to do? Oh, sorry, I drew an extra bond here for carbon. But then I have carbon to carbon double bond. I'm going to keep my hydrogen here, and I'm going to move this one here as well. It's still the same. I'm going to take these 2 carbons and draw them at the bottom here as this C2, 1, 2, 3, 4, 5, H5, and have my H at the top here. That's the first step you should always do when you're trying to draw out a polymer. The next step would be to open up that double bond. So what am I going to do? I'm just going to take this double bond, open it up like this, boom, and then draw my brackets. So your answer should look something like this. Let's have a look. Well, of course it can't be this one because there should never be 3 carbons in your polymer unit. Then let's have a look at the others. This one has like a CH and a CH on like opposing sides, so it can't be this one. And this one also has like a CH3 and a CH3 on the same side, which can't be this one. This one is the same exact thing that we have, if you can notice, like this one, but it's just flipped, which is nice. This, so that's my answer is D. Does that make sense, everyone? Hopefully it does. Yay, okay, good. Nice, if you guys got that, very good job. Okay, it says, what is the explanation for the malleability of metals? And if the person who's asking about the previous one, so the previous one, why the answer was D, because both of our electronegativities, if it's an alloy, they're both metals mixing to form an alloy, okay? So they both must have low electronegativities because they're metals. So if they have low electronegativities, the difference between them should be low, and the average of them should be low. So the reason why we picked D is just because it was the lowest out of all the options. It's one where you have to make assumptions. Hopefully that makes sense. Okay, makes sense. Good, good, good. Delocalized electrons. Okay, what are we thinking? Bonds are strong. Bonds are weak. The bonds involve free electrons. The bonds do not have a specific direction. Okay, a lot of you guys are saying C. Nice, exactly. Very good. P, you said C a lot. Yeah, exactly. Good. Because they involve free electrons, well, actually, it wouldn't be C. And they're being mean with the phrasing. Do we call them free electrons or are they delocalized electrons? Are delocalized electrons free? Are they free roaming? Perfect. Someone said D. Exactly. Our answer is actually D. And this is very mean of IB because basically they just want you always, whenever you mention delocalized electrons, you reference them as delocalized electrons. Okay? Free electrons are not the same thing as delocalized electrons. So here they're being so rude, but this would have to be delocalized electrons. Bonds are weak. That's not true. Metal bonds are strong. Okay? And the bonds of the metals are strong, but that does not allow for malleability. That's why A is not correct. The bonds do not have a specific direction. Yes, that's true. They do not have a specific direction, so I can bend them to my preference. That's why D is correct. What does the length of the bond pointing out of the bracket mean? It doesn't mean anything. They're just trying to confuse you. They're literally being rude. They're just basically, because usually you're supposed to write it like this, okay? And they wrote it like this, so they made space for them to write it. Okay? So they're just being rude. Nothing about that bond should be long or short, doesn't matter. So they're just showing that. Okay, I'm just gonna read the questions. Would you say finals are harder than specimens? 100% harder than specimens. Specimens are usually considered really easy, and everyone gets a heart attack when they answer the finals because they're so shocked. What is length of the bond pointing at? Oh yeah, sorry, explain that. Can you explain 10? Can you explain 10? How do you improve your exam skills? Practice questions. Do as many past paper questions as you can. I hate IB, me too. So someone said no, it means that it's bonded to other but1es. Yeah, so that's the definition of a polymer. So the bracket here just means that it's bonded to other but1es. I think what they were referencing in the previous question is why is this one so long? And the reason why this one's so long is just because to make space to write this one. Okay, but any dash should always mean, no matter the length, is that it's bonded to other but1es. Okay. Okay, yay. No worries, no worries. Is it okay, guys, if I redo 10? Because someone who's not understanding 10. Or do you want me to move on? If the majority says we move on, I'm sorry, I'm going to move on, and then I can come back to this one later. Is this higher or found? It's an SL paper. Move on. Okay, I'm so sorry. I'm going to come back to it at the end, okay? It says, which functional groups are present in this molecule? Or if the person who didn't understand 10, maybe you could rewatch the video as well. It's uploaded on YouTube. Like if you're getting annoyed that we're not doing it. Or else just wait and I promise I'll get back to it at the end. Okay, so functional groups are present in this molecule. I'm going to zoom in so you guys can see better. If you do bio, this kind of can help you. Because amino is not really actually no, it is. What are we thinking for 12? Someone said D. This is chem. Yeah, I know it's chem. But you kind of need to know about monomers a bit in chem. So usually we're familiar with the term amine, not amino. So if you do bio, it's helpful because you know an amino acid. A lot of you guys are saying D. If you said D, try again. If you're saying A, good job, George. Georgie, I think, or George, I don't know. But good job, you said A, which is exactly right. So we're going to have a look at why it's A. So an ester group, what's an ester group? An ester group is when you have a C, double bond O, bonded to another O, bonded to a C. That's an ester group. Okay? Just like so. So where can we notice that? We can actually notice that in lots of places. So one here and one here. So we definitely know we have an ester. and it's not an ether. So we can cross out B. Okay, next we have a carboxyl group. Do we see a carboxyl group? No, they're trying to trick us. This is what we would have assumed to be the carboxyl group. But we already know that that's part of what? That's part of the ester group. So that's why we can cross out C and D. And that's why my answer has to be A. Okay, so this one you would answer it by process of elimination. And then, sorry, the amino, of course, is just nitrogen bonded to hydrogens. And if you do bio, you can just know it's like NH2. What really helped you study for chem? Like, how did you study other than the crash courses? The past papers. I did so much past papers because I know it's annoying, but because I did the crash course, I reviewed all the content and I just did past papers. So find something quick to help you review the content. So you can do like YouTube videos. I don't know, but focus more time on questions than on reviewing the content. What grade science is this? This should be grade 12. What is an allox? So you don't need to know for your IB exam. So the way they would want you to answer this is by just, process of elimination. So don't worry about that. Hey Daria. Okay. There's no carboxyl. Good. Okay, I'm gonna move on. Even HL, yeah. Even HL, you don't need to know. In which block of the periodic table would element 199 be placed if it is found in the future? Okay, I'm gonna open my periodic table. So if you guys also can open the periodic table. Because unfortunately, I wish I could switch for you guys, but I can't. So 199, maybe I can draw out the periodic table. Okay, the periodic table will be like this. Okay. Like this. Like this. And then like this. And like this. Okay, and you start at 1. And here you end at 118. And then you go here and here. And this starts at like 58. And this ends at 103. Okay, so that's how your periodic table looks. So if I have 118 here and I add an element, it would just go back to the S block here, right? It would just loop back around to form another layer of the periodic table. That's why my answer is going to be A. Does that make sense, everyone? What exam is this for? This is for the IB exams. Okay, nice. Perfect. I'm gonna move on. Just waiting to see if people. Did you get a 7? I did. I got a 7 on all my papers and my IA, which I'm very proud of. Okay, it says, which is correct alternative representation of this molecule? And, oh wow. All right. What is the correct representation of this molecule? This one would be, it wouldn't be a hard question, but I would say it would take me forever to answer in my exam. So if you're not very good at like identifying things, I would skip this one in your exam. Yeah, why is this all that? Yeah, me too. I hate diagrams. Actually, that might be a bit better than, you can't see. Oh no. Okay. Can you see like this? We have A, we have D. D, okay. I'm just gonna do this. 1, 2, 3, 4, 5, 6, okay. 1, 2, 3, 4. 1, 2. What does A show? A shows there's 3 carbons. Sorry if you can't see. In here, if you count the green dots, it's 4 carbons, so A cannot be correct. Let's have a look at the other one. So this, if I drew it out, would be chlorine bonded to a carbon, bonded to another carbon, double bond, carbon, CH3, bonded to a Cl. So how many carbons do we have? We have 1, 2, 3. Again, no, I have 4 carbons in my diagram. That's why B is incorrect. Next, I'm going to have a look at C. C says 2,2-dichlorobutene. So the way I would answer this to make sure it doesn't look like a diagram is I, of course, would draw it out by myself. So 1, 2, 3, 4. And then dichloro both on the second carbon. So chloro and chloro. And again, that does not look like my image. So that's Therefore, my answer has to be D. Does that make sense? Where can I find the specimen papers? Just search up like IB specimen paper chemistry. It should show up online. Okay, good. Moving on. The block structure of the periodic table groups elements according to which characteristic. Oh, this one would be a lovely question to get. So yeah, I definitely think the specimen paper is much easier than you would get on the exam. If y'all still solving, I'm so confused. Okay, we have an A. We're talking about groups. Is it atomic number? Atomic mass? What are we thinking? Nice, a bunch of you guys are saying C. Exactly. It's based on the electron configuration. So, why do I know that's electron configuration? Well, the number of groups tells me exactly how much valence electrons are in my element, okay? So if we're talking about valence electrons, we're talking about electrons, you can kind of make those two connections. It's the electron configuration. It's not the reactivity, because actually the periodic table is not grouped in any form of reactivity. We can, like, connect the way the periodic table is structured and like make connections between the activity and the electronegativity and connect that with the energy levels in the groups. But this is something that you induce from the periodic table. It's not how it's structured according to that characteristic. And this is not true and this is not true because it's not ordered by this and this. Period is how many shells, correct? Exactly, good. And groups is about valence electrons, perfect. Do you have a YouTube channel, different teachings? We don't have we have a YouTube channel where we upload like the lives we go on, so definitely go subscribe to that. For the teachings of different sections, we have a crash course on our website. So if you'd like to join that, you can go ahead and join that. Okay, next, moving on, it says which set of conditions describe a reaction in which the reactants are more stable than the products. Okay, reactants are more stable than the products. I'm going to give you guys a hint. So, what are we thinking? If the reactants are more stable than products, I drew an energy level diagram to help you. Is it exothermic? Is everything hot endothermic and cold exo? So the opposite. Cold is endo, and then hot is exo. A lot of you guys are saying B. Very good, guys. Exactly, B. Because you can take a look at this energy level diagram to help you. This is an endothermic energy level diagram. How do I know that the reactants are more stable than the products? Well, because something that has high energy is not stable, okay? Here's my reactants, here's my product. I can clearly see that my products have a higher energy. Okay, it's overcoming a bigger gap. That's why it's endothermic. Why is it positive? You just have to remember that endothermic, the delta H is positive, and for the exothermic, delta H is negative. If that makes sense, everyone, please let me know. Very good, guys. A lot of you guys are saying B. That's a good sign. Okay, which enthalpy changes can be calculated using the bond enthalpy data? Let me know what you're thinking for this one. So bond enthalpy data, I'm going to zoom in. Hopefully you guys got the question. Okay, I'm getting a D. Careful when you say D. Is this SL or HL? It's SL. But if you're HL, you can also answer these questions. I'm going to scroll upwards. I think I've answered all the questions. B, good. Can you zoom out? Of course I can. Okay, some people are saying B, some people are saying C. Okay, so if you said B, you're correct. The reason that is because can someone tell me what type of reaction this is? You should be able to recognize this. What is it when you burn something in oxygen? Combustion, exactly. And what do we see is formed in this combustion reaction? Is it water vapor or water liquid? Like water in gaseous form, water liquid. We see it in liquid form. And we know the bond enthalpy data must only be done on gaseous form. Okay, that's why my answer has to be B. And of course, automatically this. Now keep in mind that if this was a gas form, then you could answer D. Okay, nice. Which is a renewable energy source? If you do bio, this might help you also in answering. Is coal a good energy source? Coal actually produces climate change. So no, not that one. Good. A lot of you guys are saying D, wood. Perfect. Exactly. Wood is a renewable energy source. Natural gases are not good energy sources, and this is just a trick one to trick you. Okay. Because uranium would actually be radioactive, which is not good at all. Natural gas, you would assume it to be, but actually it's not renewable. It can actually lead to more greenhouse gases. That's why wood is the answer. Next, it says, what is the amount in mole of H2O produced for a reaction between 10 mole of C2H3Cl, 10 mole of O2 if the yield is 90%. I'm getting an A. You got this paper in your mocks. And how did you do? This question's scary. It's not scary. We're going to do it together. Don't worry. It should not be scary. No, what I get you. I hate moles. Okay, I'm getting another A. Nice, guys. You're answering it very well. So the first step, I'll give you a hint, is try to find the limiting. Which one's limiting? Is it going to be the oxygen or is it going to be the other one? If you can, guys, get us to, like, let's say like an unbelievable number. Say, if you guys can get us to 10K likes, I don't know what we're going to do, but we're going to do something crazy on live. Okay, so first of all, you guys have found the limiting. How do we find the limiting? We just take the 10 moles and divide it by the coefficient out in front. So 10 moles first divided by 2 gives me 5 moles. And then 10 moles divided by 5 gives me 2 moles. So I know for a fact oxygen is the limiting. Very good, guys, who said oxygen is the limiting. So the limiting is what I'm going to use to help determine how much H2 is produced. Okay, so if I have 2 moles here, and I apply that ratio here, that means I make 4 moles of H2O. Now, what is the key thing? The key thing is to remember that the yield is 90%. So I actually have to do another step and take it further. So how would I know that the answer is this one? Well, you can kind of process by elimination. So always remember in multiple choice, you can kind of eliminate stuff. Okay, it can't be something higher because it's 90% yield, so it only makes 90% of this, so it can't be 9, and it can't be 10. And of course it can't be B because you're making something that is less yield. Okay, so you can just do you can do 4 times 0.9. Let's see what that gives us, times 0.9, and you would have been able to answer that the answer is 3.6. Okay, that's why the answer is A. Does that make sense, everyone? Is this A level or GCSEs? It's IB. It's 4 moles because you add the two ratio with the 2 mole. You don't add it, you multiply it. Careful. So it's 4 moles because 2 times 2 is 4. Doesn't make sense. Not going. Okay, let's do it again. No worries. Don't worry about it. Okay, so I'm going to ask you at every step where it's getting confusing. All right, so does it make sense that I say this has 10 moles and this has 10 moles? And therefore I need to find the limiting because the limiting thing is what determines how much products I make. Okay, good. So in order to find the limiting, I'm going to divide by the coefficient. So 10 divided by 2 is going to give me 5. And 10 divided by 5 is going to give me 2. And the smallest number is my limiting. So because this is smaller, this is limiting. Does this make sense so far? Okay, so now because I have 2, so in 1 out of 5 of these oxygen molecules, I make 2 moles. In 5, I make 10 moles. But basically, the point of finding the limiting is finding that I know that one of these oxygen molecules in 1 molar ratio creates 2 moles. Okay, so in order to find that ratio in correspondence with H2O, you have to apply that idea that there's 2 H2Os here. Okay, so you're going to take this 2 and multiply it by the 2 out here. So 2 times 2 gives you 4 moles of H2O. Does that make sense? Okay, if that makes sense. Okay, good. That makes sense. So usually you would create 4 moles. But when someone conducted this experiment, they only obtained a 90% yield. What does that mean? They only obtained 90% of what they assumed they would get. Okay? That's when they mean percentage yield. So usually these questions, is it always this way? It's always this way. Once you find the limiting, you just multiply that one ratio of the limiting by the coefficient. Now make sure you don't multiply the big 10 number. You always multiply the smallest number by the coefficient. So if it's 4H2, then you make 2 times 4 instead. No. It's 2H2. Oh, yeah, sorry. If you're saying, hypothetically, if there's 4 H2Os, you would make 2 times 4. Very good, exactly. So you calculate the 90% of 4. Exactly. How do you calculate the 90% of 4? You just do 4 times 0.9. So 4 times 0.9 would give me 3.6. What I was trying to tell you earlier is that if my 4 is what I'm supposed to make, and the person who conducted this experiment only got 90% of what they were supposed to make, you can kind of assume that it can't be B. It can't be anything higher than 4. So you could have just said the answer is A. But if you also can calculate it, 4 times 0.9 gives you 3.6. Hopefully that makes sense, guys. Yep. Yay, guys, we're almost at 10K. Okay, nice. I'm going to move on to the next question. Okay, hopefully it made sense. Okay, I'm going to move on. So the complete combustion of 20 centimeter of gaseous hydrocarbon, this here, produces 80 centimeter of gaseous product. This volume reduces to 40 centimeter when the water vapor present condenses. All volumes are measured at the same temperature and pressure. What is the molecular formula of this hydrocarbon? Wow, that was a lot of words. Let's break it up. Let's break it up in a second when I plug in my computer to chart. Okay. It says large deposits of methane hydrate here have been discovered under the ocean floor. What is the mass of carbon dioxide to be produced by the complete combustion of 12 grams of methane? So here we have CH4, 6H2. I'm combusting it in complete oxygen, and I'm producing methane hydrate. So I'm producing CO2 plus H2O. Okay, and it's asking me, what is the mass of carbon dioxide? Question mark when I combust 12.48 grams of this. This is another hard question, but hopefully we're able to solve it together. So the first part of this question is just simply balancing out the equation, right? How do I balance the equation? I count how many carbons. Here I have 1 carbon, here I have 1 carbon. So carbon 1, H. How many hydrogens do I have? Here I have 6 times 2 is 12. 12 plus 2 is going to give me, sorry, not 12 plus 2. 12 plus 4 is going to give me 16. And then oxygen I have 6 plus this 2 here, which is going to be 8. My hydrogen here is going to be 2. My oxygen here is going to be 3. So clearly I need to balance out my hydrogen. So I'm just going to put on an 8 here to see if that helps. Let's see what that gives us. That gives us 16. And that gives me 8 oxygen plus 10. Okay, so now I have 10 oxygens here. 1 carbon, 1 carbon. So now my issue is my oxygens. Okay, so I have 6 oxygens coming from here. So then I would have to put a 2 out in front so I can get 4. And that would give me 10. So I have 1 and 1 carbon. I have 16 and 16 hydrogens. And I have 10 and 10 oxygens. Does this make sense first, how I balance out the equation? Okay, so now that I've balanced out my equation, what is the next step? The next step is to apply the molar ratio. So I need to find the moles so I can apply the molar ratio and see exactly how much carbon dioxide I've produced. So to find the moles, I'm going to do 12.4 divided by the molar mass they've given me, which is 124. 12.4 divided by 124 is going to be 0.1. 0.1 moles. Applying that ratio with the moles of carbon dioxide, because it's a 1-to-1 ratio, I can say 0.1 moles of carbon dioxide were produced. Therefore, if 0.1 moles of carbon dioxide were produced, I just do 0.1 moles times the molar mass, which should give me 440. So the answer is A. The oxygen number, what is that? It's a 2. Sorry, my handwriting is a bit messy. But makes sense, everyone. Why the answer is A. If yes, I'm going to move on. Yes? Okay, perfect. Next, it says, wait, where did you get where did the 0.1 come from? That's the mole number. Because I have the grams divided by the molar mass, okay? And because I know that this has a 0.1 mole, and this has a 1-to-1 ratio, that means the moles of the carbon dioxide is going to be equal to the moles of the methane hydrate. So I just did the moles times the molar mass. Okay? How do you know the mass? You mean the molar mass? How do I know the molar mass? I just do like CO2, 12 comes from the carbon, and then 2 oxygen, so it's plus 16 plus the mass. It tells you the mass here. The 9. This is not the 9. This is, sorry, my handwriting's bad. It's grams over molar mass. No worries. Okay, next question. It says that the diagram shows the energy profile of the reaction. Which combination is correct? The activation of the forward reaction, the activation of the reverse reaction. So this is our forward reaction, and the purple will be our reverse. What is everyone thinking? Is it A, B, C, or D? Thank you guys for getting us 10K likes. Okay, a lot of people are saying B, or one person said B. C, okay, I have a C and a B. I think this is the first time we've hit 15K likes on a live, so thank you guys very much. B, B, D. Okay, let's work it out together. So the activation energy I know is going to be basically the length of this bump here. Okay, so in order for me to get the length of this bump, what do I have to do? I have to do Y minus Z. Oh, that's not an answer option. Okay, wait, that's how. So X is definitely not the activation energy of the forward reaction, because that's just the energy level of the direction. Y minus X. Ah, yeah, Y minus X also gives it to me. Sorry, I was working out with Y and Z, but in this case, they also did Y, Z, no worries. So Y minus dx gives me my activation energy. So it's definitely not going to be Y. It's definitely not going to be X. So it has to be B or D. Okay. And then what about the reverse? The reverse is the same thing, but I'm just going this bump here. Okay. So that's why my answer has to be B. Did that make sense, everyone? Sorry, I got a bit confused in the beginning. But let me show you basically the point. The reverse reaction, this is the little bump. This is the activation energy. And this little bump is of the forward. Yes, makes sense. Okay, good. What is the main reason for an increase in the rate of reaction when the temperature is raised? A greater proportion of collisions are successful. Particles collide more frequently. The bonds in the reactants are weakened. The activation energy of the reaction decreases. Nice. Someone said B. What else are we thinking? B. Nice, guys. Exactly. B is the correct answer. The greater proportion of collisions are successful? No. So we know that the probability of a proper collision to occur is the same. But when you collide more things more frequently, you essentially allow for more of this collision to occur, and then you can end up having more successful ones. But the proportion should be always the same. And if you are HL, you should know that that's represented by an A value when you're talking about kinematics, okay? Sorry, kinetics, not kinematics. The bonds are weakened, no. The activation energy of the reaction decreases, no. What is the thing that decreases the activation energy? Is it temperature? There's only one thing that does it. Can anyone recall in the comments or in the chat? The catalyst. Very good. Exactly. What is the equilibrium constant expression for the following reaction? We're talking about the Kc value. So what is the Kc value in this case? Can anyone tell me? Does Kc have pluses and minuses? Does it even have pluses, Kc? A lot of you guys are saying A. Kc doesn't even have pluses, so we can already cross this one out. Let's have a look. Kc doesn't have coefficients on front, so cross them out. A good way to help you answer and make sure you've picked the right one is to be able to cross things out. And we see that this is products over reactants, applying the ratio as a exponent, which is exactly what you need to do. That's why my answer is A. The reason why it's not C is because this is doing reactants and products at the bottom, which is incorrect. Very good, guys. You guys are doing very well. Which reactions involve the transfer of a proton? So when we're thinking of a transfer of a proton, we can also just think of a hydrogen ion, and this would be acids and bases. Yay! Okay, guys, we have 5 questions left. Let's see. Is this acids and bases? It is acids and bases. Let's see if you guys can get us to 20K in the last 5 questions. We're almost done. Thank you guys for paying so much attention. And I know some of you guys have been here since the beginning live, so very good, guys. I hope you guys get all the 7s you deserve. So let me know what you're thinking. Which one's going to be the transfer of a proton? One and 3, very good. Someone said 1 and 3, exactly, good. How did you notice it was 1 or 3? Will you guys be uploading on this on YouTube? We will be uploading this on YouTube. It is 1 and 3. Oh no, not 1 and 3. Sorry, it's not 1 and 3. But 3 is correct. It's not 1 or 3. 3 is definitely correct. Because we see the hydrogen going from here and going to our H2O and carbonate. So 3 is correct. Is 1 correct? What is this chem? It is chem. Now, why is 1 not correct? Because there's no transfer of a proton. The proton is just leaving in this case, okay? So it's just leaving and going by itself. You're bonding the Cl to magnesium, and the hydrogen is just being left alone. There's no transfer. Here, there's a transfer because this is taking the O, bonding it to the hydrogen, and then the magnesium is then taking the HCl and bonding it to it. So they're transferring, they're exchanging things together, okay? So nice, exactly. If you said C, that's the correct answer. It's 2 and 3, because you see an exchange. This is becoming magnesium chloride, and this becomes H2O. Now here you also see an exchange. It's stealing its oxygens, and in return it's giving its chlorine. So transfer, think of exchanging, is it 2 ways. 1 is clearly 1 way. That's why we cannot say it's 1. Did that make sense, everyone? It is C. Good job. Okay, I'm going to move on. Yay, we're at 16K. Good job, guys. Okay, we have 4 questions and we have 4K likes. Okay, next it says the overall reaction occurring at the electrodes of a rechargeable metal hydride battery can be summarized as this. Which statement is correct? What are we thinking? Hello. You're guessing. Did you get it right with the guessing? Hopefully you did. Maybe you'll be lucky on your exam. The oxidation state of nickel does not change. M is oxidized by loss of hydrogen. The oxidation state of 1 hydrogen changes from -1 + 1. The oxidation state of oxygen changes from -1 to +2. So this one, hopefully you guys can answer it. A is incorrect for sure. Yes, you're correct. A is incorrect for sure. We can cross that out because the oxidation state of nickel does change. Now, for this specific question, there's an irregularity. And I actually remember making a slide about this for the chemistry crash course that's coming up. I do go through exam questions, so we do go through them in our crash course, if that's what you mean. Or if we've gone through them in live, we have as well. There's some up on YouTube if you'd like to watch those. Yay, we're at 17K. Good job, guys. Okay, we have B. All right, so to try to find exactly what's going on here, we're going to take a look at our oxidation states. So we know that metals, okay, or metal hydrides, there's an irregularity. Why? Because usually hydrogen has a charge of +1, an oxidation state of +1. But only in metal hydrides, where there's an exception, that Hydrogen has a charge of -1. Okay, why? Because it's just metals we know, like Na plus, Mg2 plus, K plus. All of these metals always like being positive, and because metals are stronger, you can think of them as more bossy. They like being positive. They like staying what they are. Okay, so because they're positive, it forces our hydrogens to be negative. And this is just an irregularity you have to remember. So this is going to have plus something. Unfortunately, I don't know what the metal is, so I can't even name exactly what that metal is, but I'm just going to have it at plus 1 charge. Why? Because I know that the ratio between the hydrogens and the metal is 1 to 1, because I don't see like a 2 here, or I don't see a 2 here. So then I know this is +1, this is -1. My metal here goes to being 0. I know that my OH group is going to be -1. That's just something you have to memorize as well. And so then I have to try to find my nickel and my oxygen charge. I know, of course, that my oxygen is -2 charge. So that means my nickel had to have been +1, so that the overall charge would have been, sorry, +3. +3 -2. So that the overall charge when bonded to an OH, it would be -1. And when it bonds to an OH, therefore, it has a charge of 0. Okay, next, this becomes -1, of course, but because there's 2 of this, this is -2, so then I know it becomes +2. Does this make sense, everyone? Why that's the case? How do you know that M is +1? Why can't it be plus? Okay, so basically, you know how like when you have like magnesium bonded to hydrogen, because magnesium is 2 plus and hydrogen is like -1, when it crosses each other, it should be MgH2. Here, because there's no 2, I know it has to be a +1 charge. What subjects are you guys doing for IB? Okay, nice. Hopefully that makes sense why it's +1. Does that make sense, everyone? Okay, so let's have a look at the answer options. The oxidation state of one H atom changes from -1 to +1. Okay, that makes sense, right? Because here I have a -1 hydrogen that goes to a +1 hydrogen. How do I know it's +1? Well, because if I take a look at my OH minus separately like this, my OH minus goes from being O2 plus and the hydrogen being, O2 minus. I'm getting my charges confused. O2 minus, from this being +1 to an overall charge of -1. So I see how this goes from -1 to +1. And that's why my answer is C. Of course, we've eliminated A. The oxidation atom of the oxygen goes from -1 to -2. No, we know that it goes from -2 to -2, so no, it can't be D. M is oxidized by the loss of a hydrogen. How do we see? Do we see that here happening? No, M is being reduced. Okay, why? Because my oxidation number is decreasing. That's why B is incorrect. That's why we have an answer C. Does that make sense? Are we going to do an HL paper 2? If you guys would like for us to do an HL paper 2, it's going to be, we can do one as well. Okay, nice. Hopefully that makes sense. Just tell me in the chat if that made sense and I'm going to move on. I know it's one of the harder questions. Isn't it supposed to add up to 0? For what, which one, why is it reduced? Because the oxidation number is decreasing. Yes, it makes sense. Okay, nice. I'm going to move on. Flower, can you just tell me what you're referring to when you're talking about, like, isn't it supposed to add up to 0? I'm not sure because I moved on. Okay. NiO. Okay, so if you look at NiO, like this, NiO, bonded to an OH minus, like this, basically what we're looking at. Okay, this is the compound they've shown us. I know OH minus is going to be -1. Okay, so therefore I know that this overall thing has to balance it out to be plus so that it can be a neutrally charged compound like this. That's why I know it should equal to +1. Does that make sense? Okay, good. All right, someone's asking if I could repeat C. If a lot of people are not understanding this, I'm gonna re-explain, but if you guys are understanding this, I'm gonna move on. Move on. If there's lots of yeses, I'll move on. If there's no, I'm gonna stay. When is the next live? They usually just occur like once a week. It depends on my availability. So if you want to keep up to date, if you go on our like profile, it says like the live is scheduled. It tells you when the next live is scheduled. Is this HL? It's SL. Okay, good. A lot of people are saying yes, so I'm gonna move on. It says in a redox titration, manganate ions are reduced to manganese ions, and iron ions are oxidized to iron 3 plus ions. What volume in centimeter cubed of 0.1 manganate is required to reach the equivalence point in the titration of 20 centimeter of 0.1 molar Fe2 plus? Wow. What a long-worded question. And if I got this question, I would cry on my exam. But it's actually not that hard, and we'll work it out together. Okay? So, the first thing you need to do is you need to write a balanced equation so you can find the molar ratios, just because this is a titration question. Always with titration questions, you just apply molar ratios. So, let's have a look here. Okay, so the first step I'm going to do is just going to try to write the equation. Now, I know with redox equations, it's a bit different because I have to write the half equations and then combine them together to make one full equation. So I'm going to write the half equation of iron. And then I'm going to write the half equation of the manganese and the manganate. So because my iron is being oxidized, that means my electrons are being added to the right side of my equation. Or you can also think of it because this is a +2 charge, this is a +3 charge. I need to add 1 electron so they're both +2 charges. Okay, next I'm going to write the half equation of manganate. So MnO4 minus goes to Mn2 plus. I can see that my oxygens are not balanced out, so I'm going to add 4 H2Os on this side. Okay, now my hydrogens are not balanced out, so I'm going to add 8 hydrogens on this side. And then I see that my charges are unequal. Here I have a +2 charge, here I have a +8 charge, and a -1 charge. So they should be +2 and +2. So how many electrons do I need to add here? I need to add, I believe, 5 electrons. Let's see, -1 gives us the 7. So yeah, exactly. 5 electrons will give me an overall charge of +2 on the right-hand side, and also overall charge of +2 on the left-hand side. Now that I've written my half equations, I need to add them to make one equation. How do I do that? I just make sure that my electron ratios are equal. To make the electrons ratio equal, I'm going to multiply this side by 5 so that it ends up being 5 Fe. Okay, like this. 5 Fe3 plus and 5 electrons. Once my electrons are balanced, I can cancel this, and then add my equations. Now, it would be MnO minus plus H plus 5 Fe2 plus to form 5 Fe3 plus Mn2 plus 4 H2O. What is the point of all this? The point of all this is just to try to find. Someone said it's a bit long for one more question. It's very long for one more question. It's really annoying. Basically what I teach my students is, because IB always, for redox titrations, they only ask for iron and manganate. So always I teach my students that just remember that the ratio is 5:1. But I can't say that now because I know not a lot of you just remember that. Okay, that's something you have to like write out. But if you do a lot of these questions and if you know the IB very well, and you know the syllabus, they only ask for iron and manganate. So the equation is always going to be the same. So whenever you see redox titration, you can literally just remember 5:1 ratio. But of course, oh, something happened to my screen. But of course, if you guys don't know that, I can't just jump ahead and do that. So it is a bit long for 1 mark, but the IB know what they're doing. And that's what they're kind of assuming, okay? So that's what we know in the next step, that is this is 5:1 ratio, okay? So if I have 20 centimeter cubed of 0.1 molar of iron, I can find the moles by doing N is equal to CV. The concentration is 0.1. The volume is 20 divided by 1,000 because it has to be in decimeters. 20 divided by 1,000 is going to give me 0.02 times 0.01. No, 0.1. That's going to give me the number of moles to be 2 times 10 to the negative 3. And because I have 5 to 1 ratio, what do I have to do? I have to divide this moles by 5 to try to find how many moles of manganate there is, which will give me 4 times 10 to the negative 4. And finally, I just have to find the volume. So now that I have the moles of the manganate, which is 4 times 10 to the negative 4, I know the moles, I know the concentration because they've given it to me. I just have to divide the moles by the concentration to get the volume, and that will be divided by 0.1, and that should give me a final answer of 4. That's why my answer is B. Does that make sense, everyone? Same as last year, deja vu. Yeah, it's horrid. Okay, thank you. Yeah, it's very long for 1 mark. I'm gonna ensure that you guys be very good, guys. I think I didn't miss any questions, but hopefully that makes sense. Confusing, too long, but yes. Okay, yay. Okay, I'm gonna move on, but if you guys remember, like, write down the question number, I can explain it later. This is what is the organic product of the reaction of chloro-1-pentane? So 1, 2, 3, 4, 5. Chloro-1 with sodium hydroxide. If you're finding a lot of these questions confusing, I really recommend for you guys to join our crash course. I will be tutoring part of the chemistry crash course, and it will be the same exact thing like this, but I'll be teaching you the content and teaching you the tricks as well, okay? So if you didn't know this manganate to iron thing, I would have told you in this crash course and you would have been up to date. And it's not the only time that IB does this, so keep in mind, okay? What are we thinking for the answer here? So chloro-1-pentane with sodium hydroxide. We know this is a substitution reaction. What are we substituting? We're substituting our chlorine with what? Our hydroxide, because we know our chlorine is negative, our hydroxide is negative, so they're just gonna substitute each other. So what do you actually end up forming? Can anyone tell me? 1, 2, 3, 4, 5. Substituted with an OH. I'm just taking the spot of the chlorine because OH is more reactive than chlorine. I end up forming pentan-1-O, an alcohol. Very good. Everyone that said A, perfect. I think if I join April 15, the crash course starts April 15, I think. Wait, let me just check my calendar. The crash course starts on the 19th of April, so you should be more than okay. You would still be able to finish the whole crash course. You'll be live even. Do you do ESS? Unfortunately not, but where did the chlorine go? It just went away. It just, because this will be like a lot of chloropentane and a lot of sodium hydroxide. So you'll actually end up forming the alcohol plus like a lot of chlorine gas. The chlorines will bond with the chlorines. Is the crash course for free? Unfortunately not, but it's the cheapest crash course out there. I promise. If you compare it with like Oxford crash courses and other crash courses, they're all, not even just Oxford, but all the other crash courses available online, they're all like 500, 600. So for SL, it's like roughly 100. I'll show you at the end, but it's like 100 something, 120, I believe, because it's 5 days, all on the weekend. You get all the resources, all the slides, and then for HL, it's more expensive. I don't know the exact number, so if you guys wait, I can just show you at the end. But let's move on to the next question. So which statements explain the following reactions occurring in the upper atmosphere? This one's an annoying question because I don't know what the point of this is, but it's part of the syllabus, so you have to do it. I'll show you the crash course page at the end, guys. Oh, we're at 18K! Just because I know some people are joining this to do questions and it's like they don't want to be held back. No, CFC. I know I hate CFC. I know. Okay, what are we thinking for this question? So, the chlorofluorine compounds break down to produce chlorine radicals, but usually not fluorine radicals. Why is it not fluorine radicals? Again, it's a bit annoying to tell you this, but usually I teach my students that you actually will never see fluorine radicals, but fluorine radicals, if you ever see them reacting in a homolytic fission, okay, it's way too strong. Someone said D, exactly, very good. It's way too strong, it actually explodes. Oh, it actually explodes. Why does it explode? Because the electronegativity of fluorine is way too strong. That's why I can cancel out my options A and C, because fluorine is much stronger. And let's have a look here. It says chain termination step causes chlorine radicals to reform chlorine molecules. Chain propagation step produce more radicals. Exactly. Termination step cause chlorine radicals to form chlorine molecules. That's not actually what happens. Our answer is B, because we have to think of the homolytic. So if you know free radical substitution, you know that the propagation step exactly produces more radicals. Okay, that's the whole point of the propagation step. That's why my answer is D. Are you the founder of this account, like the TikTok? I'm not the founder of Easy7. Easy7 has been alive and well much more before I joined. I even actually joined the crash course myself, and then I was interested in helping them out. And actually, if you've done the crash course, you have an opportunity to help us out as well. How do you know it's the propagation step? Just because you know, so there's something called an initiation step. Like you just have to memorize them. Initiation, propagation, and termination. And because it says, the termination step is incorrect in this case, and actually you can even, without knowing the initiation propagation step, you know the thing that produces CFC is the propagation step. Like you just know it, because the issue here of producing CFC is that you have this really unreactive things called radicals. These radicals have electrons that are unbonded with each other, okay? And the whole point of creating CFCs is by having these very bad things bond with other bad things. And that's what causes greenhouse gases. Okay, so that's why it's definitely not this one. If you didn't know the initiation termination step, and it's this one because it mentions the production of more radicals. Hopefully that makes sense. Oh my god, we're at 19K. Good job, guys. Yeah, but as I was saying, I'm not the founder of Easy7, but I helped create the TikTok, and I make most of the TikToks. Okay, so which species can act as an electrophile? An electrophile, think of file. This is really annoying, but yeah, think of file. There's another word you can think of, but it just means liking. Okay, electrophile, electron liking. So if something likes electrons, it has to be what? Something that likes what? Anyone tell me? I'm getting a lot of B's. Very good, guys. It is actually B. So if something likes electrons, it has to be positive. Why? Because electron deficient, perfect. Or it has to be positive. Positively charged. Exactly. Very good, guys. It has to be positively charged because opposite charges attract. Okay? So if these opposite charges attract, I know it can't be negative and it can't be negative. Now, CH4 definitely does not have any charges. So by process of elimination, you could have set it to this. But the reason why it's Cl2 is because actually you have a dipole-induced dipole. So in your chlorine atom like this, one of these induces a negative charge on one of these chlorine molecules, and the other therefore induces a positive charge, and that's why it can act as an electrophile. Why not A? Because A cannot have any positive or negative charges. A is a neutral. It's nonpolar. Okay, so the only reason why it's B is because there's a dipole-induced dipole. But aren't halogens negatively charged? Yes, you're correct. Halogens are always negatively charged, but you can induce dipoles. So what do I mean by inducing dipoles? Basically, I have my Cl and Cl here. If I take something that is really, really, really positive and I bring it near this Cl molecule, I'm going to force this one. Like imagine the electrons in my Cl molecule surrounding it. And I bring something that is really, really strongly positive. All my electrons are going to get scared because they don't, sorry, not my electrons, all my, guys, I said it wrong. I'm going to re-explain. It's been a long day. I just came back from uni. Oh, sorry, but basically I have my negative. This is something negative, okay? I'm going to get something that's really, really negative. I'm going to take this negative, and then I have my electrons surrounding it. If I take this negative charge thing around there, okay, it's going to scare all my electrons, and all my electrons are going to come to the side here, okay? They're going to go away. And if my electrons come to the side and go away near, basically, the chlorine, it's going to force this to be negative and force this to be positive. Okay, that's why you induce a dipole. It repels. Very good. Which I